I personally believe that if we fix energy, we will fix the climate. Energy is the climate problem and the solution. So, energy from Climate Watch data. Of course, the different datas are a few numbers are a bit different, but roughly 75.7% of the greenhouse global emissions are from energy. So, for those of you who do not know greenhouse gas emissions, of course, the experts will dive into it. So, today, maybe now I will break it down. So, we are here for global warming, and greenhouse gases are the ones that is causing this warming. And these emissions, we just call them carbon emissions because a large proportion of it is carbon dioxide. So these emissions, a majority of them comes from energy. And if you break it down, you can see that around 30% of this energy is from electricity and heat. And then there's transportation and manufacturing and construction and so on and so on. And also, maybe I'll make a distinction between electricity and transportation, which I'll come back for point 4. So transportation is where energy is more mobile. You can transport it around. And electricity will be more stationary. And we need to know this distinction because the solutions for one another is not the same. And so because energy is the highest producer of carbon emissions, what should we do? Should we just reduce? Should we just reduce our energy consumption so that energy carbon emissions goes down? We can, but not everyone can. So that brings me to my second aspect, energy poverty map. So from this, you can see the colors. The dark red ones are the countries which consume the most amount of energy per capita. So that's Australia, North America, Western, Northern Europe. And you can see the other parts, like the darker yellow to brown parts, are the countries which do not consume a lot of energy. And if I break it down even further, there's this map. It's still a second point out of my 4 points, but the map shows energy consumption per capita over income per capita. And you can see that there are no low energy rich countries. It's just very difficult, if not, from the graph, it shows that it's impossible. But then some of you might say money is not everything. Then I would show you another graph, which is Human Development Index. So this measures education, healthcare, and quality of life. And this is also a linear correlation, which means it's directly proportionate. So from this, I just want to show you that and make these points that energy is needed. Energy is the main player. It's not the big bad villain. It's the main player. We need energy. But what we need to do is we just need to decouple energy from carbon emissions, and that means decarbonization. So just some pictures to show you how poverty looks like so that there's some empathy in the room, because we're in Singapore and it's very comfortable, but these countries are not even far off. They are not in parts of South America or Africa. These are our neighbors: Philippines, Indonesia, Jakarta, or Indonesia. Oh, sorry, Myanmar, Philippines, Myanmar, and Indonesia. So now I'll go on to my third aspect, which would be energy density. So I feel like this, and I'll explain what that means. So density, for all the physics people or the kids, maybe I can explain to you guys. Density is mass over volume. So how much things, and if you want to have more density, so you need to have a lot of things in very little space. And so that is very important. I feel like this aspect is not really spoken about in many panel discussions, talks, and conferences. When we talk about sustainability, we should also talk about material allocation and material use. And these land area, so you can see this, for example, 0.3 meters square of a nuclear plant can produce 1 megawatt hour of electricity. And with the same power, you need a lot more room for other sources of energy. So my point here is that this land has opportunity cost, and you can use it for other things like education, healthcare, agriculture. There's many other things you can do with it. So this is one important point that we should also consider when we talk about sustainability for energy generation. And now for those people at the back who couldn't really see, no problem. I got you covered. So there is a chart that all of you can see. This is the proportionate differences. So you can see for onshore wind, for that unit or that size to produce the same energy, Natural gas plus CCC is around that small line, and nuclear is 4 times less. And you can also see solar PV, coal power plus CCS, which is carbon capture and storage, and hydropower. And that brings me to my final point. So just 4 points to make this short. One more chart I would like to show you guys is the energy Sankey diagram. So let me just bring you through it. Is there a laser in this? No laser, no problem. So I can just break it down into, if you look here, this is where the energy generation starts. And we can just zoom into just one part, the orange part, electricity generation, because that was around 30% of the carbon emissions of globally. So if you look at electricity generation, these are the sources. Also disclaimer, this chart is from US on average of all the states in 2022. I wanted the latest charts, but from IEA is not out yet. So we're just going to look at this as a case study, just to explain my point. So in electricity generation, these are the sources that goes into it. And then it goes into, for example, here, residential, commercial, and industrial. But can you guys see the gray part, the gray portion, the pipes, the gray pipes, which are going all the way to rejected heat? Even over here, if you look at petroleum, which if you notice, it doesn't go to the same sources because it's transportable, it's mobile source of fuel. A huge portion of it is gray and is rejected as well. So my point here is that a lot of our energy is being wasted, is being rejected. And so another point that we need to consider on an energy day is energy efficiency and energy reduction wherever it's possible. So of course, not everyone can do that. For example, when I talked about the energy poverty map, for us in Singapore, we can talk about 25 degrees Celsius, we need to maintain the air-conditioned rooms and buildings. But in those countries, they are just thinking about, will my children can study after the sunset? Can our food be available for us after one day? So there are different considerations. So we need to look at all these different factors. So maybe I'll just recap. So that was just my 4 points to open today. So first point was that energy is the largest source of carbon emissions globally. Second point was energy poverty, to just show that we also need to think about equity. And number 3 was about energy density. We should also think about resource and material usage, critical minerals, rare materials. And fourth point was basically about energy efficiency and reduction. And so I would just want to say that I truly, genuinely believe, and my team as well, that if we fix the energy, we fix the climate. Energy is the climate problem and the solution. Thank you.